Okay, in our last video, we were playing with right-angled triangles, and we met these three guys, sine, cos, and tan. We saw how they aren't numbers themselves, but they're these machines that need you to feed them a number, namely an angle, like the one labeled theta in the picture, and their job is to take that angle and give you some fraction that compares side lengths. So sine tells you opposite over hypotenuse, cos tells you adjacent over hypotenuse, and tan tells you opposite over adjacent. Okay, do go back on the previous video if you've forgotten exactly what these mean, or the colors might remind you. So a typical problem could be to work out the side length marked here given an angle and another length, like the 5 we see. First thing we'd want to do is to identify the three sides. I find it's easiest to start with the hypotenuse, because that's probably the most familiar one. So we shoot across from the right angle and find that it's the 5. That should be the hypotenuse. We'll just write it h for short. Then I like to go for the opposite next, so we shoot across from that 20-degree angle that we've been given. And we find that this blank side is the opposite. We'll just write O for short. And the final side must be the adjacent, so we'll write an A there. Next thing is to see which of these sides we're interested in. Now I want to use the given 5 to work out the length of the x, so it'd be helpful to look at those two sides. Notice the opposite side is blank, there's nothing useful going on there, so we don't really care about that one. Okay, it seems in this case, we only care about the adjacent and the hypotenuse. So we look back to the left and see which of these machines compares the adjacent with the hypotenuse. And it looks like it's the second one, the cosine. So we write cosine. But remember, we need to feed it a number. And the number we give it is the 20-degree angle. Then its job is to give us a fraction with adjacent on top, so that's the x we're looking for, and hypotenuse on the bottom, so the 5 we were given. The order matters with division, so make sure you're noticing which one's upstairs and which one's downstairs. So now at this point, we just need to solve this equation for x. So to get rid of the divide by 5, all we do is multiply both sides by 5. And so that means x just equals 5 times cos 20. Now cos 20 is just a number your calculator can do, right? We interpreted it last time as getting some percentage of that 5, but the point is you can now just punch 5 times cos 20 into the calculator and you get something like 4.70 or something. Okay, let's try another one. So we'll start the same way by identifying the three sides. So we shoot across from the right angle and find the hypotenuse is blank this time. We shoot across from the given 50-degree angle, and that's our opposite, which has a length of 3. And finally, the adjacent must be the x we're looking for. So we need to use the 3 to work out the x, which means we're comparing the opposite and the adjacent, once again leaving out one of the sides, which this time is the hypotenuse. So on the left, we find which machine relates opposite with adjacent, and that's tan. And so that's the machine we'll choose. Once again, we need to feed it the angle we're given, so the 50 degrees this time, and be very aware of who goes upstairs and who goes downstairs. So tan always puts opposite on top, so the 3 goes up there, while adjacent goes on the bottom, so x goes there. Now, because in this topic we'll see this sort of equation appearing so much, it will be helpful to have a sort of one-step shortcut that's really just using a symmetry of division. Here's what I mean. Let's just use some numbers, say 5 equals 10 divided by 2. Then there's a symmetry between the 5 and the 2, and that means you're allowed to actually switch them around. So 10 divided by 5 is 2, just as 10 divided by 2 is 5. Okay, and you're probably aware that this is true when you're dividing any numbers. It actually boils down to the fact that multiplication can happen in any order without changing the result. So 5 times 2 is 2 times 5, and so on. Okay, so that's why there's that symmetry around division as well. Point is, you can swap the bottom number of a fraction around with the other side of the equation. And so we can rewrite the equation with the same 3 up top. Only now the x and tan 50 switch places. And that's super helpful here because it gives us the length we're looking for in one step. It's just 3 divided by tan 50 this time. So we punch that in a calculator and get something like 2.52. Okay, so that's how we work out side lengths. We identify which two sides we're trying to compare. We choose the appropriate machine, either sine, cos, or tan, depending on which sides we're given and which ones we're trying to work out. And then we solve the equation we get, okay? And that should only take 1 or 2 steps. Okay, just be careful which one goes upstairs, which side goes downstairs, and so on, okay? So that's all for this one. Thanks for watching. See you next time.